Hello and welcome to episode 11 of Chemistry in 15 Minutes or Less. My name is Audra and this review lesson is on chapter 6 and 7, part 4, Molar Mass. Now if you recall from an earlier lesson, 1 atom of carbon-12 is equal to exactly 12U, and 1 mole of carbon-12 is exactly 12 grams. These are basically just our standards for atomic mass. We're going to go over them again. But to determine the molar mass for either a polyatomic substance or an ionic compound, I have to follow this formula. I'm not going to write out the formula, I'm just going to do an example. Say we have, trying to find the mass of potassium nitrate. You have 1 mole of potassium. See, 1 mole of potassium times its molar mass in the periodic table, plus, as you can see, 1 mole of nitrogen times its atomic mass in the periodic table, plus 3 moles of oxygen times its molar mass in the periodic table, which equals the molar mass of the entire compound. Now the other thing you can calculate at this point is what's called formula mass. Formula mass is the mass of one molecule, formula unit, or ion of a substance. It's equal to the sum of the average atomic masses of all atoms represented, which is basically the same as the molar mass, but with different units. You say 1 atom of potassium plus times, this is the weight per unit or whatever. It's just the same thing. Now the next formula we're going to talk about is something called percent composition. Now, percent composition is basically the percentage by mass of each element in a compound. Now you calculate this from a chemical formula and molar mass, and the formula is percent equals the mass of one part of the formula over the mass of the entire formula times 100%. Now let's do an example with, say, sodium sulfite. Now, if we're trying to find the percent of sulfur in sodium sulfite, you would take the mass of sulfur over the mass of the entire compound times 100%, which means, which we'll do here, is you have 1 mole of sulfur times its molar mass divided by the molar mass I already have calculated times 100%. Basically, you're assuming 1 mole of the substance, which is why you don't have the grams per mole, which means the percent of sulfur is 25.44%. Now, what you can do with percent composition is you can take it and determine something called the empirical formula. Now, the empirical formula its really wordy definition is basically that it consists of the symbols for the elements combined in a compound, with subscripts of the symbols showing the smallest whole number mole ratio of the different atoms in that compound. Basically all that means is it uses atomic symbols and subscripts to show the smallest mole ratios possible. Now we're just going to do an example because there's 2 different ways you can do this. You can either do it with an equation or with a table, which is basically the same thing, but they're laid out in different ways. It's whatever's easier for you. So the formula for empirical formula is moles of a substance equals mass over molar mass, but then what we really need is mass times 1 over molar mass. So we'll continue to do this. So basically, let's say we have a substance that is composed of 36.7 grams of potassium, 33.27 grams of chlorine, and 30.03 grams of oxygen. Basically, we need to find moles of potassium, moles of chlorine, and moles of oxygen in this mystery compound. So you take your numbers here, you just write them down so I don't forget them. Times, you have, per 1 mole of the substance, you have whatever the molar mass in the periodic table is, assuming 1 mole, gives you how many moles are present in this substance. So we're assuming 1 mole all the way down. what you need to do is you have these three numbers here, and you need to divide each of them by whatever the smallest amount of moles on the table is, which in this case is our friend chlorine. So when you do that, you end up with 1 mole of potassium to 1 mole of chlorine to 2 moles of oxygen, which means our formula is KClO2, which is potassium chloride. Now, like I said, there is a table method of doing this, which gives you the same answer, but some find it easier to do it this way. Basically, the table requires the percent composition instead of having it in grams, so you have your element name, followed by percent, or a mass in grams, assuming 100 grams, the molar mass, then you have the moles of the element you get back, and the smallest, which gives you the end, your mole ratio. So in this example, we have potassium, chlorine, and oxygen, and we'll use the mass in grams because these add up to 100. The molar masses stay the same. Same molar masses from the periodic table. Pretty easy, usually out to 4 sig figs. And it gives you back the mole of the element in moles. Which you then divide by the smallest mole. Basically what you're doing here is also dividing. Which in this case is, like we said, our friend chlorine, which will give you back the same mole ratio of 1 to 1 to 2, which still gives you potassium chloride. Now that was a lot in a short period of time, but this is a very important lesson. We do a lot with you having to determine the empirical formula. But still, this should conclude episode 11 of chemistry in 15 minutes or less. Feel free to leave questions or suggestions in the comments below, and be sure to follow the in-video links, check out the playlist, or head over to my channel for more videos on chemistry review. As always, I hope this was helpful, and have a great day.